The first thing that we're going to talk about is functions. This first section that we're covering is on functions. And all a function is a correspondence between two sets. The domain, which is the values for x, and the range, which is the values for y. So as an example, I've got this function, f of x, and that's how you would say this. Not f times x, but it's f of x, or a function of x, equals 2x plus 3. Now, f of x is just the same thing as if a y was there. So this might be the same thing as y equals 2x plus 3. But instead, we're going to talk about this in terms of functions, because as you get into higher math, you're going to work with functions more than equations. So this function, f of x equals 2x plus 3. In this function, the domain refers to x. So the domain is all the values of x that go right here in the function, okay? And x is called the independent variable because it can be any number. Well, mostly, because remember, we're going to find the domain, and sometimes the domain is limited. The range refers to y, okay? Y, or f of x, both the same thing, is called the dependent variable because its value depends on what the value of x is. So whatever x we plug in, we're going to get a y or an f of x out of this. That variable, the y or f of x, depends on what x is. Okay? So the domain is x, the range is y. Now, at the bottom of this page, we're going to do a comparison of equations versus functions. And first of all, it says, evaluate the given expression if x equals 4. Remember, we did this months ago. So if we want to evaluate the given expression if x equals 4, it just means we're going to plug in 4 in place of x. So this is how we would do it. 3x minus 1 equals 3 times 4 minus 1, which is 12 minus 1, which is 11. Now, in function notation, this statement means the exact same thing. If f of x equals 3x minus 1, find the indicated value. And what we want to find is f of 4. All this means is that we're going to plug the 4 in place of x. So if f of x equals 3x minus 1, then f of 4 equals 3 times 4 minus 1, which is 12 minus 1, which is 11. And the way that we state our answer is like this. F of 4 equals 11. Now, something else that's interesting. If we have the equation y equals 3x minus 1, the point, remember this is an x, and f of x equals y, the point 4, 11 is a solution for this equation. Now, of course, there are many other solutions, but this is just one solution, okay? Let's go to the next page, and we're going to practice finding some function values. All right, it says, find the indicated values for the function f of x equals x squared plus 2. Now, over here in the box is something interesting. Your book sometimes writes this like this, which I find very bizarre. And pretty much no one else does it, but they do. But it means this, okay? So if we want to find f of 3, this would be x squared, or 3 squared, plus 2. 3 squared is 9, plus 2, which equals 11. All right? F of negative 5 is negative 5 in parentheses squared plus 2, which is negative 5 when you square it. Negative 5 times negative 5 gives you positive 25 plus 2. which is 27. All right, f of 1 is 1 squared plus 2, which is 1 plus 2, or 3. F of 0 is 0 squared plus 2, which is 0 plus 2, or just 2. Now, we can plug other things into our function other than just numbers. We can plug variables or variable expressions into a function. And the next two examples are examples of that. So f of a equals a squared plus 2. And f of 3b equals 3b in parentheses squared plus 2. Now, when we square 3b, this is 3 squared b squared, so 9b squared plus 2. And that's as far as you can simplify it. All right, at the bottom of the page, we have an example where we're going to find the range of a function. So given f of x equals the absolute value of x minus 3, and the domain, remember, the domain is the x values. So if they tell us that the domain has these 5 values, we're going to plug those 5 values in for x, because the domain is just the x values. And it says find the range of f of x. This is the f of x or y values. All right? So what we're going to do is plug in each of the 5 values for x. Those 5 answers are the members of the range. So we've got to do this 5 times. So we have f of 0 equals absolute value of 0 minus 3, which is the absolute value of negative 3, which is 3. F of 1 is the absolute value of 1 minus 3, which is the absolute value of negative 2, which is 2. F of 2 equals the absolute value of 2 minus 3, which is the absolute value of negative 1, which is 1. F of 3 is the absolute value of 3 minus 3, which is the absolute value of 0, which is 0. And then we have f of 4, which is the absolute value of 4 minus 3, which is the absolute value of 1, and that is just 1. Now notice, 1 is in the range twice. That's okay. We only have to write it 1 time. All right? We don't need to write it twice in our range set. So in our range set, I have 0, 1, 2, and 3. All right? Even if a range value occurs twice, you only include it once in the range set. All right, let's go to the next page. Finding the domain of a function. This is a little different. And this requires some memorization. For the most part, you can plug any value in for x. So we would say the domain of a function is actually all real numbers because you can plug anything in to your function. But sometimes there are certain kinds of functions that you can't do that. And the reason you can't do that is because you won't get an answer. When that happens, we have to exclude those values from our domain. So our domain won't be all real numbers. It'll be something smaller than that. All right? So finding the domain of a function, this means finding the values that x can be. This may seem strange since x is the value we plug into the function, and you may be thinking, don't they usually tell us what to plug in? And yes, they do. However, finding the domain means asking oneself, are there any numbers that I cannot plug into the function? And yes, there might be. That will occur if 1 or both of these two situations occur, all right? And there's two situations which will limit your domain. All right? First of all, the domain of a function is all real numbers unless one of the following is true. Number one, if the function is a fraction, any value of x that makes the denominator equal 0 must be excluded from the domain. So in other words, we can't make our denominator 0 because you can't divide by 0. That's not a number. It's undefined. So we can't put a value in for x that will make our denominator 0. So we have to figure out what values would make our denominator 0, and we have to exclude them from our domain. And this is how we would do that. I have an example here. If f of x equals 2x over x minus 3, then x cannot be 3. All right? Because then we would have 3 minus 3 is 0 in the denominator. All right, so the domain of this function is the big R, all real numbers, except x cannot equal 3. Now, the way you figure out what it cannot equal is you take your denominator and do this. Say x minus 3 cannot be equal to 0. Add 3 to both sides. X cannot be 3. All right? That's how we figure out what x cannot equal. There is a second thing that will limit your domain. If the function includes a square root, then the domain is the set of values that make the value of what is under the square root sign greater than or equal to 0. Here's why. If you have a square root, try on your calculator to find the square root of a negative number. For example, we know the square root of positive 4 is 2. If you try and find the square root of negative 4, you're going to get an error. An error. Because nothing times itself is going to give you a negative number. Because to get a negative number, you need one positive and one negative. All right? So nothing times itself. 2 negatives times the self is still going to give you a positive. All right? So whatever is under the square root cannot be negative. It has to be positive. So, as an example, if f of x equals the square root of 2x plus 1, here's how we're going to figure out our domain. That 2x plus 1 has to be greater than or equal to 0. This is the key. And we're going to solve that. So subtract 1 from both sides and we get 2x is greater than or equal to negative 1. Divide both sides by 2. And we get x is greater than or equal to negative 1/2. So here's my domain in this case. My domain does not start out with all real numbers. It's just this. It's all the values that are greater than negative 1/2 or equal to negative 1/2. All right, so it doesn't have and all real numbers anywhere in this domain. So what we're going to do next is go through some examples. So, first of all, it says give the domain of each function. Now, I've got to ask myself, do I have a fraction and do I have a square root? I do have a fraction. The denominator cannot be equal to 0. So here's what I'm going to do. Set x plus 1 not equal to 0. Subtract 1 from both sides and I get x cannot be equal to negative 1. My domain is all real numbers except x cannot be equal to negative 1. This is my domain. Now, with this one, I have fractions, but it's not limited because I don't have x in a denominator. This denominator is never going to be 0, it's 4. This denominator is never going to be 0, it's 6. There's no x in the denominator, so there's no way a denominator can be 0. There is no limitation. So the domain is just all real numbers. All right, let's go to the next page and we'll do some more examples. In example A, when we're finding the domain of the function, we have a fraction, but the denominator does not have x anywhere in the denominator. The denominator, therefore, can never be 0. It is 3 all the time. So our domain is all real numbers. If we go to B, we do have x in the denominator. So here's what we're going to do. Set x squared plus 1 not equal to 0. Subtract 1 from both sides, and we have x squared cannot be equal to -1. But here's something interesting. When can something squared be negative? Because a negative times a negative gives you a positive, and a positive times a positive gives you a positive. What happens is this can never occur. So there are no exclusions. And our domain is just all real numbers. So just because you have a fraction doesn't mean something will be excluded. It's only excluded if it makes your denominator equal 0. And nothing is going to make this denominator equal 0. All right, let's take a look at C. We have a fraction again, and we have two things multiplied in the denominator. If either one of these two things is 0, the denominator will be 0. So x plus 2 cannot be equal to 0, and x minus 3 cannot be equal to 0. Subtract 2 from both sides, and we find x cannot be equal to -2. Add 3 to both sides, and we have x cannot be equal to 3. So my domain is all real numbers except x cannot be equal to -2, x cannot be equal to 3. And this is my domain. Now if we go to D, there's no fraction here, but there is a square root. And remember, this cannot be negative under here. It's got to be greater than or equal to 0. So to find our domain, set 3x minus 4 greater than or equal to 0. Add 4 to both sides. And we have 3x is greater than or equal to 4. Divide both sides by 3. And here's our domain. X is greater than or equal to 4/3. There's no all real numbers involved in this particular situation. All right, let's go to E. Again, I have a square root. What's under the square root has to be greater than or equal to 0, so set x plus 5 greater than or equal to 0. Subtract 5 from both sides, and we get x is greater than or equal to -5. My domain is x is greater than or equal to -5. I could not put a -6 into this function because that is not greater than or equal to -5. I could put +2 in this function because it is greater than or equal to -5. But nothing less than -5 can go in this function. All right? Let's go here to F. I have both of these things going on. So I have to look at both parts. I have a square root and a denominator. So first of all, my denominator cannot be 0. So x cannot be 0 simply because I have x all by itself. The other thing is x squared plus 2 must be greater than or equal to 0. Subtract 2 from both sides, and I get x squared is greater than or equal to -2. Now, this isn't going to create any exclusions because anything squared is positive, and any positive number is greater than or equal to -2. Since this doesn't create any exclusions, we're only going to use this. So my domain is all real numbers except x cannot be equal to 0. All right, let's go to the next section, and we're going to talk about relations and functions. So we've got some definitions to start with. First of all, a relation is any set of ordered pairs. Remember, ordered pairs are x comma y in parentheses. So if we have a set of those, it's a relation. A function is a relation in which different ordered pairs have different first coordinates. So what this means is each x is only in the set one time. Each x is only in one ordered pair. So if you have two ordered pairs that have the same x, so if you have the point 1, 2 and the point 1, 3, not a function. You can't have two different y's with the same x. It's not a function if that occurs. All right? The domain, we talked about this, is the set of first coordinates in the ordered pairs, the x values. The range is the set of second coordinates in the ordered pairs, the y values. So we're going to do some work with functions and relations, and we're going to use our Desmos app on our iPad to help us through this process. So the question is, how can you tell if a relation is also a function? There's this thing called the vertical line test, and a relation is a function if and only if no vertical line intersects the graph more than once. And we're going to do some graphs, and I'm going to show you how this works. But we have some of these that are just sets of ordered pairs that we can look at and we can see if it's a function. So if we go to A, I've got a 1x value, a 2, a 2, a 3, and a 4. This is not a function because the 2 value occurs twice with two different y values. So this is not a function. Not a function. Let's go to our graphing calculator and we'll put this function, y equals absolute value of x plus 3. And we probably remember what this looks like. And here it is. And what we can do is you can use a pen or a pencil or a ruler to do the vertical line test. And the vertical line test says no matter where you put your vertical line, which is the edge of my ruler, on this graph, it never crosses the graph more than once at a time. So it's once, 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 all the way to this side. Only once is it crossing this graph. So it is a function because it only crosses the graph once at a time. All right? So we're going to say that this is a function. The next example, we have ordered pairs. Look at the x values. I've got a 1, a 2, a 3, and a 4. No repeats of x values. It is a function. It does not matter that the y's repeat. It does not matter. It only matters if the x's repeat. So this is a function. Take a look at D. We've got an A, a B, and a C as our x values. All different. So this is a function. Doesn't matter what the y values are. The next one, let's graph on our graphing calculator. Y equals x squared plus 4. So I'm going to go back and put in a new function. Y equals x squared plus 4. And if we look at this, and you put your ruler or your pencil down, it only crosses that vertical line once at a time. So this is a function. This is a function. It'll make more sense when you see an example where it's not a function. Okay, the next one, y equals the square root of x plus 1. So let's see what this one looks like. Okay, there's this function. Do you think this is, or do you think this will be a function? Does it pass the vertical line test?
No.
It's only crossing once. Only crossing once. Only cross once. Never did it cross more than once. So it never crossed more than once, so this is a function. Let's try the next one. Y squared equals x minus 1. Okay, now take a look at this. Let's do this vertical line test. There's my vertical line. How many times does it cross? Twice. Not a function. It crosses my vertical line 2 times. It is not a function. All right, the next one is 2x plus 3y equals 6. What do you think? Is it going to pass that vertical line test?
Yes.
Yes, it is. Never does this graph cross that vertical line more than once at a time. So this is a function. The next one, absolute value of y equals negative x. What do you think about this? Pass or fail?
Fail.
If you look right there, how many times does it cross? Twice. This is a fail. This is not a function. And the last one is a set of points. Is this a function or not a function?
Not a function.
Not a function because the x value of 1 is represented 2 times with two different y values. So this is not a function.